It's Algebra 2, spring test. This is really only test number 5, but I'm calling it 7 to make it match the week, so don't freak out if you see test 7. Study guide. Number 1 says write these expressions as single logarithms. You remember with addition, remember when you're putting stuff together, you work your order of operations in the order that it is. Please excuse my dear Aunt Sally. That 2 up front, you actually have to take care of first, that 2 up front. So what it's going to act like is it's going to say the log of base b of y is going to be to the second power. And we'll do the same thing with the 7. We'll bring that one over there. So plus log, again, base b of q to the 7th power. So that's the first thing, is moving those coefficients in front of the logarithms to the back, moving them as exponents. The second part, just again following your order of operations, is to undo, not to undo this, but to actually do this addition. Remember, addition pairs with multiplication. So all you have to do for this is log base b of y squared times q to the 7th. And this is written as a single logarithm. Since both of the bases are b, y squared times q to the 7th. We'll do the same thing with the other one, except we don't have to move coefficients at first. We just have to undo, not undo, I keep trying to say it like that. We just have to do this subtraction. Just like addition went with multiplication, subtraction goes with division. Again, both of these are log base 6. So log base 6 of 16 divided by 4. And we could actually simplify that and even go further and say log base 6 of 4. Number 3 is going the opposite direction of what we just did for number 1 and number 2. This says log base 2 of m divided by 2. If subtraction went with division, then division goes with subtraction. So we'll say log base 2 of m minus log base 2 of 12. And that's it, expanded. All you have to remember for the test tomorrow is that multiplication goes with addition. Division goes with subtraction. When you're doing it, you work it in a normal order of operations order. When you're trying to undo stuff and move it across the equal sign, that's the only time you undo stuff and go backwards. Use the properties of logarithms to evaluate log base 3 of 9 plus log base 3 of 36 minus log base 3 of 4. All of them are log base 3. So what we're going to do is we're going to combine these. We're going to condense it. Okay, we're going to make it smaller. You just work your order of operations from left to right. Addition and subtraction are the same priority, so you work from left to right. So this is simply going to be log base 3 of 9 times 36 minus log base 3 of 4, and then we'll keep going condensing that. 9 times 36 is going to be log base 3. We know 9 times 6 is 54, carry 5. 9 times 3 is 27, plus 5 is going to be 324. All that was combining these two, minus log base 3 of 4. So then you take care of the subtraction part now. Again, there's still log base 3, so we can combine them and make it log base 3 of 324 divided by 4, because subtraction goes with division. So when 4 goes into 32, it goes into it 8 times, and it goes into 4 1 time. So you wind up with log base 3 of 81. Now, if we use the change of base formula, we can go further than that. We'll leave that for the problems that are later with actually for the change of base formula. Number 5 says to solve 11 to the 8x power is equal to 92, round to the nearest 10,000th. Now, before we went on a Mardi Gras break, we talked about changing bases. There are no bases that we're actually going to change in use different exponents, different powers of those on this test. We'll do that on the next test. But since we can't change 11 and 92 into the same base, then we have to take the logarithm of that first one to get 8x by itself. So the way we're going to do this is we're going to say log base 11 of 11 to the 8x power is equal to log base 11 of 92. So what that did is all we did was took a log base 11 of both sides. The reason we used 11 is because that is what's being raised to the 8x power, which we want to get by itself. Remember, when you take log with a base of the same number, which is what we did that on purpose, it eliminates that for us. So what it gives us is 8x is equal to log base 11 of 92. So in order to get x by itself, divide by 8. So that's just regular algebra 1 right there, divide by 8. So x is equal to, and we're going to have to estimate this, log base 11 of 92 divided by 8. Now, most calculators won't plug it in just like that. You have a change of base that you have to look at, this part right here, log base 11 of 92. The way you do that is you do it as log of 92 divided by log of 11. Remember, the base is the one on the bottom. So the way you're going to get the correct answer out of this is you're going to punch it in just like this. So the way you're going to do this is you're going to punch it in just like this. When you press log, it's going to open up a parentheses. You're going to put 92 and then close the parentheses, divided by log again. It'll open up a parentheses 11, close the parentheses again, divided by 8. When you punch that in just like that, you're going to get the correct answer, or you get an estimate of the correct answer. All right, now when I punched it in, I got this 1.200, and I got times 10 to the 91st power. Anybody? Okay, we got something that didn't turn out to be exactly like that. What you need to make sure to do is to put a set of parentheses around that before you divide by 8, and you should get what you're supposed to get. Okay, again, some calculators act a little differently. They do order of operations exactly how you punch it in, and some of them will do it in the way that it's supposed to follow. If you add just one more set of parentheses, you're going to get approximately 0.2357. It says round to the nearest 10,000, so that's tenths, hundredths, 1,000s, 10,000s, and then a 1 comes after that. So that'll give us what we need right there. Approximately 0.2357. Okay, and then this is almost identical to the last problem. It says use change of base round to the nearest 10,000. So the same thing. We're going to take the log base 6 of both sides because you have to get rid of that 6 to the 5x. You want to get rid of that 6. So again, equals log base 6 of 98. This one is going to cancel out, which is what we were trying to do. So what you have is 5x equals log base 6 of 98. And again, to get x by itself, you have to divide by 5. So again, it's an identical problem to the last one with just different numbers. You're going to have to add that extra set of parentheses for some calculators. Some of them you won't. But when you punch it in, you're going to punch it in like this. Log 98. Remember, you're changing the base. You have to change this. So what that means is log of 98 divided by log of 6. So log 98 divided by log of 6, and then close that extra set of parentheses right there. Then hit divide by 5, and that should give you what you need. And I got 0.5178. And again, that fourth digit will give you what you need as far as to the nearest 10,000th, 0.5178. Okay, so we have 0.51, lost a 1 somewhere in my translation, 0.51178. And since it only wants 10 thousandths, we don't have to go to that 8. So we'll round that one up to 0.5118. That's your nearest 10 thousandth one right there. Okay, dividing and simplifying these. All you have to know about these is since they have the same index, you can divide 120 by 3, just as if it was like 120, the square root of each of these. So what that's going to give you is the cube root of 40. And that's as far as we're going to need to go with that. We don't have to simplify further than that. Same thing with the fourth root of 160 divided by the fourth root of 5. You have to know that they're the same. So you can divide that by that. 5 goes into 16 3 times, and there's 1 left over. It goes into 10 twice. So it's the fourth root of 32. Okay, we're going to do the same thing with these, except there's variables that are put in there. So 80 divided by 5, 8 goes into 5, 5 goes into 8 one time, and there's 3 left over. 5 goes into 30 6 times. So it's going to be the cube root of 16, but you have x to the 21st power divided by x to the first power. You subtract exponents. So instead of dividing that, like we did 80 and 5, you're going to do x to the 21 minus 1, which is x to the 20th power. And we'll do the same thing with the other one. Divide 144 by 2, and you're going to get 72. So the square root of 72. And again, the same thing with the x's. You do 26 minus 1 to get x to the 25th power. Add these if possible. This radicals act just like variables. If you had 4x plus 4x, you'd add 4 and 4 and get 8x. You're going to do the same thing with this one. You have the same square root of 7x, so you're going to add 4 and 4 and get 8 times the square root of 7x. And the same thing's true with number 12. They're both the cube root. They both have the same index, and they're both 10a. So it's a cube root of 10a. So you just do 4 minus 6 is negative 2 times the cube root of 10a. So just treat them just like terms with variables. Okay, simplifying 19 to the 1/2 power times 19 to the 1/2 power. Remember, this is talking about, this is your index, and this is what you raise it to. So if you made this into a radical form, it'll be the square root, you don't have to write that 2 right there, but it's the square root of 19 raised to the first power. That's the radical form. The reason it's easy to change this into the radical form is because you can see what it is a lot easier. Times the same thing, the square root of 19 to the first power. There's no reason to write the square root, and there's no reason to write the first power. So what we have is the square root of 19 times the square root of 19. And anytime you multiply the same radical by itself like that, all you do is take the radicand from underneath it, and that's what it's going to wind up being, 19. Okay, change 14 into the radical form. Again, this is your index. So it's going to be the cube root of 27 raised to the second power. The cube root of 27 means what times itself 3 times is 27. Well, we know that that's the number 3. And 3 squared is 9. (15) says to write this one in radical form. So you're going to do the same thing with this one. This is 6 times x to the 6/5. Only x is being raised to the 6/5 power. So it's going to be 6 times the 5th root of x, being raised to the 6th power. This is radical form. Where people will make mistakes with something like this is they'll try to put the 6 inside of the radical like that. It doesn't go there. The only thing being raised to the 6 over 5 power is the x. Writing this one in simplest form. Now, the difference between this one and number 15 is 27 and a to the negative 6 is being raised to that negative 2/3 power. So when you distribute it to both of them, you have 27 to the negative 2/3, and you have a. Now that's negative 6 times negative 2/3. Negative 6 times negative 2 is positive 12, and 12 divided by 3 is a to the 4th power. So then we can convert 27 into the negative 2/3 power. So right there, all that means is this is the index. So the cube root of 27 being raised to the negative 2 power, a to the 4th. Remember, all a negative power means is it's going to make it ride the elevator. We know the cube root of 27, we did it just a minute ago, it's 3. So 3 to the negative 2 power times a to the 4th power. And again, all this does is make this over 1 ride the elevator. And a to the 4th stays on top. And 3 goes down. It becomes 3 squared to a positive 2, which simplifies to a to the 4th over 9. Okay, and this is the stuff we've been working on for several weeks right here. It says simplify these, state any restrictions on a variable. Remember, all a restriction is if you're going to get something that's going to be 0, you can't have 0 at the bottom of a fraction. So factor out the top of this one. C and C gives you C squared. Then we have to use the factors of 4. There's 2 and 2 and 4 and 1. The only way to get to 5 is to use 4 and 1. This one says they're both positive, or this one says they're the same. This says they're both negative. So minus 4 minus 1 over, we'll do the same thing. C times C. Your factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. The only pair that gets you to the number 2 is 4 and 6. Again, this tells you they're different signs, unlike the other one was the same sign. This tells you the bigger one is plus. 6 is bigger, so it's plus. This one's minus. You have the same thing at the top, C minus 4 as at the bottom. That's the part that cancels out. C minus 1 over C plus 6. Your restriction for this one is C can't be equal to what? Negative 6. C cannot be equal to negative 6. That would be the restriction. Yeah, you're trying to get 0, but the way you get 0 is to put it together with positive 6 to get negative 6. Do the same thing with the other one, except the difference with this one is since it's to the 4th power, we'll just make w squared times w squared. And we'll do that same thing with the bottom. So your factors of 3 have to be 3 and 1. Same sign, both minus. So minus 3 minus 1. Your factors of 21 are 1 and 21. And 3 and 7. The only pair that gets you to 10 are 3 and 7. So those are the ones we're going to have to use. Okay. This tells you there, same sign, both minus. Minus 3, minus 7. So again, we have the same thing at the top as the bottom. That can cancel out. So w squared minus 1 over w squared minus 7. Now we could even simplify that top even further. And this is the part, like I told y'all when I first showed you the stuff, you don't know if you have to go any further or not. Because we can make that top say w plus 1 times w minus 1 since it's the difference of 2 perfect squares. But there's no reason to. There's no reason to because we're not going to be able to take away anything else from that. So w squared minus 1 over w squared minus 7. Now your restrictions on this one are going to be what, when you square it, means what times itself is going to be 0. So there's no number that's going to give us 7 when we do it by itself. So if it was just w by itself, then we would have it can't be equal to 7. but there's no restriction on this because there's no number, there's no rational, there's no integer number, there's no rational number that we can get 7 when we square it. This one's a little bit easier for most people. You're going to do the same thing. What you have to know about this one, though, is that since it's dividing, you're going to multiply by the reciprocal. So the first fraction stays just like it is, m plus 4 over m minus 6. The second fraction flips because it becomes multiplication. The bottom is going to be m plus 1. That was the top of the other one. Then you just factor out the top of, or which was the bottom of this one. So m times m. Your factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. The only way to get to 1, which we need, is to use 5 and 6. This tells you they're different signs. This tells you the bigger one's minus. So minus 6 plus 5. Remember, anytime you have the same thing at the top and the bottom, you can cancel it out. Minus 6 cancels out. M minus 6 cancels out. So what you're left with is m plus 4 times m plus 5 over m plus 1. And your restriction on this one is m can't be what? Cannot be negative 1. Because when you put it together with 1 at the bottom, it'll give you 0, which is impossible. Number 20, all you're doing is factoring this one. So x times x gives you x squared. Your factors of 45 that are going to get you to the number 14, or 9 and 5. So use 9 and 5. This says same sign, both positive, plus 9 plus 5. 21, solve the equation, check your solution. Remember, when you undo operations, you work order of operations backwards. So you work subtraction, addition, division, multiplication, exponents, parentheses. So it says minus 10 right there. You want to get to add 10 because you're trying to get a by itself. So negative 3 plus 10 is 7 equals the square root of a. In order to cancel out the square root of something, you square it. So there's no multiplication and division. It's the exponent step, exponents and radicals. That'll cancel this out and leave you with a. You have to square this one, though. So 7 squared is 49. So a is 49. 22, solve this one by finding square roots. Divide by 3. Again, you're working your order of operations backwards. X squared equals 16. To cancel out squaring something, you take the square root. That's the inverse operation. Do it there and here. X equals both plus and minus 4. Positive and negative 4. 23 says solve this one by completing the square. 38 is not a good perfect trinomial number. So subtract 38. So what you're left with is x squared plus 14x plus c equals negative 38 when you subtract it. Get your new value of c by dividing 14 by 2 and get 7 squared. So your new value of c is positive 49. When you add it to one side, though, you have to add 49 to the other side. So we have now, you want to take the square root of this, which is x, the square root of this, which is 7. This is the sign in between them. X plus 7 squared equals negative 38 plus 49 is like subtracting those. That gives you 11 on that side. So then just solve for x by undoing your operations. Get rid of squaring all of this by taking the square root of it. That'll cancel it out and leave you with x plus 7 equals the square root of 11. And then subtract 7 on both sides. So the better way to write this would be x is equal to negative 7 plus or minus the square root of 11. And then rewriting it in vertex form is almost the same thing, but you have a little bit less work to do. Move 34 over to the other side by subtracting it. Y minus 34 equals x squared plus 12x plus c. Find your c again. 12 divided by 2 is 6, and 6 squared is plus 36. You have to add that to both sides. So what that gives you is y plus 2 equals, take the square root of this is x, take the square root of this is 6, this goes in the middle plus, that's all squared, almost vertex form, subtract 2 on both sides. Y is equal to x plus 6 squared minus 2, vertex form.